Hello and welcome back to our grade 9 maths lesson. I am Mrs. Rhea, your grade 9 maths teacher. In our last lesson, we looked at transposing of formulas. In this lesson, we are going to look at inequalities. Okay, inequalities. Okay, inequalities actually compare expressions by either using less than, or equal to, greater than, or equal to. You will see that with less than, it's only one symbol here with a V shape that is facing the right. And with less than or equal to, we have a V which is facing the right with a stroke underneath the V symbol. With greater than, it is an inverted V which is facing the left. That's for greater than. And for greater than or equal to, we have a stroke underneath the V that is facing the left. Okay, so these are the symbols that we use to compare expressions, and these are the inequality symbols. We are going to look at how we can solve inequalities. Okay, so we will be looking at solving linear inequalities. Examples of solving linear inequalities, we have 3x plus 2 is less than or equal to 14. Okay, 3x plus 2 is less than or equal to 14. What do we do to solve linear inequalities? We can add or subtract on both sides of the equation. We can multiply or divide on both sides of the equation, just like what we do when we are solving linear equations. So here we have plus 2, so the first thing that we are going to do is to subtract 2 on both sides of the inequality. So we have 3x plus 2 minus 2 is less than or equal to 14 minus 2. So this cancels out. Therefore, 3x is less than 12. 14 minus 2 is 12. Now the next thing that we are going to do is to divide both sides of the equation by 3. Okay, so we have this divide by 3. Therefore, x is less than or equal to 4. Okay, so we have now solved the inequality, and we have now found a range of values that satisfy this inequality. X is less than or equal to 4. How do we show this on a number line? Okay, we are going to show this on a number line. Okay, we are all familiar with the number line. We have done number lines when we were looking at directed numbers. Okay, so let's say I have a number line, and this is where my solution starts with, because x is less than or equal to 4, I'll have to put 4 here, and I put 5 here. 5 is greater than 4. Okay, then I will write down numbers which are less than 4. We have 3, 2, 1, and the numbers continue on towards the left. So our inequality says x is less than or equal to 4. So I'm going to put a shaded dot here to indicate that 4 is also included, because that x is equal to or less than 4. And then all the numbers that are to the left of 4. So this is the solution of x is less than or equal to 4 when it is represented on a number line. So this shaded dot means that 4 is also included. Okay, and all the values to the left of 4. Okay, now let's look at the next example. Okay, our next example is 4x minus 3 is greater than 6x minus 7. How am I going to solve this inequality? I will bring all the letters to the left-hand side and all the numbers to the right-hand side. So the first thing that I'm going to bring across is 6x. If I bring it to the left-hand side, it will become negative 6. So I have 4x minus 6x is greater than negative 7. I'll bring negative 3 to the right-hand side. It will become positive 3. So I have plus 3 here. 4x minus 2x is negative 2x is greater than negative 4. Now, I have 2x, negative 2x is greater than negative 4. I am going to divide both sides of the equation by negative 2. But when we are solving inequalities, when I multiply or divide by a negative number, my inequality symbol will reverse. So in this case, since I am going to divide by negative 2, this inequality symbol now will reverse. So this cancels out. My x will be less than 2. Okay, negative 4 divided by negative 2 is positive 2. Negative 2x divided by negative 2 is x. So my solution is now x is less than 2. How do I represent this on a number line? Okay, I have a number line here. Again, these are all the numbers that are left of 2. Because it is less than 2, I'll start with 2 here. Okay, I have 2, 1, 0, negative 1, and the numbers will continue on. I will have positive 3 to the right of 2. But this time, 2 is not included because our inequality solution is x is less than 2. So I am going to put an unshaded dot here, and I'll draw an arrow to the left side of 2. So this means that x is less than 2. Okay, so in this lesson, we have looked at how we can solve linear inequalities to find the value of x and also plot this on a number line. And in our next lesson, we are going to look at how to write inequalities as interval notation. Okay, this brings us to the end of our lesson. Thank you.